Welcome to The Explainer. Today we're going to fundamentally change the way you think about gravity. Seriously, it's not some force pulling you down, it's the very shape of the universe pushing you along through time.
So let's start with a mystery, a really old one that's bugged thinkers for centuries, all the way from Galileo to the scientists working today.
Just think about that for a second. It's a proven fact. You take a feather and a cannonball, get rid of all the air, and they fall at the exact same speed. It doesn't matter what they're made of, how much they weigh, none of it. So why? Why would that be?
And believe me, this isn't just some old thought experiment. We are so obsessed with this question that we've set up these huge cosmic-scale experiments to test it. We literally shoot lasers from Earth to mirrors that the Apollo astronauts left on the moon, all just to track its fall towards the sun with mind-boggling accuracy.
The measurements show that the Earth and Moon fall toward the Sun at the same rate, matching up to within this tiny number. To put that in perspective, that's like measuring the distance from New York to LA and being accurate to within the width of a single human hair. It's one of the most precisely tested facts in all of physics.
So here's the crucial point. This isn't just some weird quirk of gravity. Albert Einstein looked at this and realized, wait a minute. This sameness is a signpost. It's a giant arrow pointing toward a much deeper and, frankly, much stranger reality.
Okay, so let's follow that arrow. Let's dive into this clue. It turns out the answer has nothing to do with a force pulling on things and everything to do with the path that they're all taking.
We've all seen this, right? You throw a ball, it makes that familiar arc. It goes up and it comes down. Simple. But Einstein, he saw something totally different. He wasn't just looking at its path through space, he was seeing its path through space-time. You know, that four-dimensional fabric that weaves together the three dimensions of space with the dimension of time. And this is the huge conceptual leap. He said objects aren't being pulled by a force at all. No way. They are simply moving along the straightest possible line they can find through a cosmic landscape that has been warped and bent by mass and energy. This one idea completely revolutionizes everything. This is the moment where gravity stops being a force and it becomes the very fabric of the universe itself. So this is the core idea of general relativity. The classic way to think about it is to picture a bowling ball on a trampoline. It makes a big dip, right? A curve in the surface. Now if you roll a marble nearby, it's going to follow that curve. The marble isn't being pulled by the bowling ball. It's just following the new straightest path on that curved surface. Well, that's gravity. This just reframes everything we thought we knew. A planet orbiting the sun isn't being yanked around by some invisible rope. Nope. It's just coasting. It's following the straightest possible line through the curved space-time that the sun's enormous mass creates. Its destiny, its path, is literally determined by geometry.
Okay, I know. This is an absolutely incredible claim. The idea that space itself is bent and curved it's pretty mind-bending. But how in the world could you ever prove it? How do you measure the shape of space itself?
Well, the answer, amazingly, comes from something we all learned back in school, the humble triangle. It turns out a triangle is the perfect tool for surveying the entire cosmos. Remember this rule. It's like a bedrock of our intuition about the world. A triangle's angles add up to 180 degrees, period. But, and this is the big but, that's only true if the surface you're drawing on is perfectly, totally flat. This shows it perfectly. Think about drawing a giant triangle on the surface of the Earth. Let's say you start at the North Pole, you go straight down to the equator, you make a right turn and walk a quarter of the way around the world, and then you head straight back up to the North Pole. You just made a triangle with three 90-degree angles. They add up to 270 degrees, not 180. The geometry itself literally reveals the curve of the surface. And get this, long before Einstein was even born, the brilliant mathematician Carl Friedrich Gauss had this exact idea. He thought, what if space itself is curved by the Earth's mass? He figured he might actually be able to detect a tiny little deviation from 180 degrees by measuring a massive triangle between three German mountaintops.
Now, he didn't find anything. The curve caused by Earth's mass is way, way too small to measure like that. But that's not the point. The really crucial thing is that he established the principle. The geometry of our universe is something we can test. It's a question for experiments, not just for abstract math.
And this is where things get really, really wild. Because we took Gauss's brilliant idea and we scaled it up.
Not to mountains, but to the size of the entire observable universe. So instead of using mountaintops, modern cosmologists use the cosmic microwave background. That's the oldest light in the universe, the afterglow from the Big Bang. By looking at patterns in this ancient light, they can form the biggest triangles you can possibly imagine, stretching across billions and billions of light years. So what's the result? After decades of incredibly precise measurements, the answer is kind of shocking. On the largest scales we can see, the angles of these cosmic triangles add up to 180 degrees. The geometry of our universe, against all odds, appears to be flat.
So let's just trace this incredible journey for a second. We started with a simple question. Why does everything fall the same way? That little clue led us to this huge revelation that gravity isn't a force at all. It's the curvature of space-time. And then, by measuring giant triangles across the entire cosmos, we found that on the grandest scale, our universe has a flat geometry.
I mean, this whole journey, from a falling feather to the shape of the cosmos, just goes to show you that some of the deepest truths about reality are hidden in the most obvious places. We just learned that gravity is actually geometry. It makes you wonder, right? What else around us is not at all what it seems? Thanks for watching.